when we look at graphs, when we look at a distribution here, they start getting into shapes. Yeah, it's true. They're bar graphs. It could be dot plots. It could be sometime information here, but they start getting into shapes. So for today, we're going to be looking at the shapes of our distribution. Now, if I was to do like a line here to go around my graph here, I started looking at the graph. I started looking at the shape. It is pretty high on the beginning, and then it starts going down. And then if I was to look on the second information here, it goes up and then down. So see, it starts getting a shape, and then that's what we're going to call, again, we're going to be looking at the shapes of the distribution. So let me scroll down here. There's a few shapes. So we're going to be talking about the names. There's 5 shapes that we're going to be looking at. The first one is symmetric. You heard of the word symmetric before, symmetrical. You've heard of this before back in geometry, right? For symmetric, you imagine a mirror line and you said one side, you're going to break your figure in half, and you're going to say one side looks like a reflection of the other side. As an example, let's say I had my graph here, and then I'm gonna say, this is how my graph looks like. I can imagine a line that cuts it right in the middle, and then one side looks like the reflection of the other side. Now, I'm not gonna say it has to be exactly identical. Look, this side right here, this gap, it seems a little bit less than this gap. Notice how I was a little bit off, and it's okay. Our data is not going to be exactly identical one side to the other side. I could have something like, and I'm still going to call that symmetric. You see my bump on the right? You see the little bump on the right? It's okay. It doesn't have to be exactly the same. It doesn't have to be identical. It has to be about the same. Keep in mind, I said about. It has to be about the same. I can imagine my line here, and one side, my left side is a reflection of the right side. That's what we're going to call symmetrical or symmetric. Now, another shape that we're going to call this left skewed. Okay. Now, left skewed and right skewed, the next two names, can be easily confused. Now, left skewed, I'm going to say the median, the highest point. The highest point, it is not in the center. For symmetric, you notice how the highest point of my graph seems to be in the center? Sometimes it is not. Coming back to symmetric, it's about that. That's a shape that is symmetric. The highest point doesn't quite have to be in the center. But now for left skew, it does have a highest point, but not in the center. Okay? The type of distribution in which the peak is on the right side. Interesting. The left skew, it's a type of distribution where the peak is on the right side, while the left tail of the distribution graph is longer. Okay, so what do I mean with this? Is imagine a graph that looks like this. That is left skew. The peak, the highest point on the graph is on the right side. You might be wondering, why do we call this left skew and not right skew? The peak is on the right side, but we're still going to call left skew. Okay, well, what it means is that the median is to the left of the mode. The highest point is the mode. You guys have heard mode. We're going to talk a little bit more on the next unit. Mode is basically the number that appears the most. So you guys can see the mode is on the right side of the graph, but there's a lot of little numbers on the left side. So it seems like all this little information on the left side are pulling my graph to the left. There's a lot of little numbers on the left side that are pulling my graph to the left. They don't pull it that much because they're small numbers. So that's what we're going to call it, left skew. My peak, the highest point on the graph is on the right side, but there's a lot of, it has a tail. We call it a tail. It has a lot of small values on the left side that are kind of trying to bring the graph to the left. That's why we're going to call it left skew. So right skew is pretty much similar. It's a type of distribution in which the peak is on the left side, while the right tail of the distribution graph is longer. Now the median is to the right of the mode. Okay, so as an example, how does the right skew looks like? The peak is on the left side of my graph, but there's a lot of small values on the right side that are trying to pull my peak. They're trying to pull the mountain, if you guys want to call it, this graph. They're trying to pull it to the right. So that's why we call it right skew. Okay, so let me go again. The left skew, the peak is on the right side, but there's a bunch of little values that are trying to pull my peak to the left, so we call it left skew. Now, my right skew graph, it has the peak on the left, but there's a lot of little values that are trying to pull the peak to the right side. So that's what I call it right skew. Now, bimodal. Now, you guys have heard of the word modes, right? You guys have heard mode is the number that happens the most. It's basically the peak on our graph. Now, bi basically means two. So bimodal, I'm thinking two modes. So there's going to be two peaks. There's going to be two peaks on my graph. Each peak is a modal. It's a mode that the number that happens to be repeat the most. Bimodal, basically two modes. So it's my graph is gonna have two peaks. Now uniform, the last one, equal spread. All my data is about the same. There are no peaks. That's what we're gonna call uniform. It is all straight. There's no peaks. It's all about the same information. So I gave you guys here some graphs here, some things here. So I'm like, okay, so what is this? Now this one, the first graph, when you look at it, it looks like this. Many people might want to call it a bimodal because you guys see two lines that go up, but not necessarily. When you do my graph around it, it only has one peak. So this thing, it looks like I could cut it in the middle. Well, that's about the middle. Let me do a better job. And it looks like the left side is a reflection of the right side. So that is what I call symmetric. That is symmetric. Now, when I look on the second graph, it looks like it has a peak and it goes down, and it has a peak and it goes down. It is symmetric. It is symmetric because I can cut it in the center and it looks like the left side is a copy of the right side, but I'm gonna say this is bimodal. I'm gonna emphasize more this bimodal. It has two modes. So it is symmetric in one point, but I'm gonna go more into bimodal. It has two peaks. Now looking on this graph, look, everything seems about the same. There's no peaks, right? There's no ups and downs. There's nothing. This is what we call the uniform. I'm looking at this third graph right here. This is uniform. It has no peaks. It's all about the same thing. Now here on my next graph, let's take a look. It looks like this. It has one peak on the far right on my graph, right? There's a lot of information on the left side. So it seems like this little information want to bring my peak to the left side, but they're too small, so they're not able to bring it. But my peak is on the right side and there's a lot of information trying to bring it to the left. So I'm going to call that left skew. My last graph, it has a peak and it has a big tail on the right side. So what is that data on the right side trying to do? Trying to pull my peak to the right side. They're too small, so they're not able to bring the peak to the right side. But this one, I'm going to call it right skewed. Okay, so for your graph, for your point, you're gonna have to create some data. So I might give you some on your questions. I will give you guys the graph, and then I'm gonna ask you which data is this. Some of them, I'm just gonna give you the numbers. Notice how here for life expectancy by state, I have a graph with dots. So if I gave you just numbers, just numbers, you can come out with the data like that. Now, each of those dots represents each of those numbers. So notice how 74 is only ones, 75 is ones. There's no 76. I see 77 and 78 are ones each, but look at 79 is 3 times. So I can give you a list of numbers, and I will expect you guys to be able to create a dot plot. So this thing that you guys see here, you guys will be able to create that. And then once you have that graph, I'm going to ask you, is it symmetric? Is it left skew? Is it right skew? Is it bimodal or is it uniform? What do you think? So again, I might give you the graph and ask you what type of graph it is, or I might just give you the information. I might just give you the data and you plot it in as a graph. And then answer the question whether it is symmetric, left skew, right skew, bimodal, or uniform.